this is the video to help you take notes and understand what our Unit 6 project is. It's called Getting Back to Where You Started, and I think as you get further into it, you'll understand where this term comes from. But essentially, we're going to build on the concept that we've been doing, multiplying in algebra, but we're going to be doing it with percents. Percents are incredibly important. You find them everywhere, from going to the store, taxes. You don't have them yet, but one day. So you really want to understand how to use them. And we've worked with them in the past. We've had several test questions that use them. But our goal today is two things. One, understanding how to set it up in an algebraic equation, and two, understanding how to set up an expression, which you'll see how they relate to each other as we go through it. But what I want you to do is make sure you have your packet out. And as we go through, what you'll do is you will take the notes as I present them in the video for each slide, and you'll notice that each slide in your packet matches a slide on the video. Also, a really good idea is to, after I've presented a question, is to actually pause and try to answer it yourself first, and then see how I answer it. If you have the same answer, that's great, because we can solve things in different ways. We just really want to make sure that we are solving it in a way that is correct, no matter what that way is. So I put our official objective at the top, which is we will write and solve equations for percent changes as size change multiplication in real world situation. At some point I'm going to be providing you questions like about the tip on a meal. So those are our real world situations. And remember, we talked about size change multiplication. We have that particular equation, how we set it up, because this type of multiplication is telling us the amount, or how much larger, how much smaller the original number will be at the end. So these are essentially your warm-up. What you should do is you should pause this now and you should go ahead and try to answer. Okay, so hopefully you've taken the time to try to work these out, and I am going to be writing or typing on here. The writing is going to be a little messy, so we'll see if I can type it out. So what is 100% of 15? Well, remember, 100% means the whole amount, so this one should be relatively easy. We know that 100% of 15 is 15. Another way we can look at it is if I turned 100% into a decimal, it would be 1, because remember, percent means for every 100, so that would be 100 divided by 100, which is 1, and we would multiply that times the original number, and I'm going to use this little star as my multiplication sign. So 1 times 15 equals 15. All right, what is 20% of 15? Now, there are multiple ways you could have worked this out. Some of you would probably say, oh, I know 20%, I can get that if I divide 100 by 5. So maybe if I divide 15 by 5, that'll give me the same thing. I'm just going to show you here the traditional method, which is we would turn that 20% into a decimal, which is, remember, 20 hundredths, because it's 20 over 100, which we can simplify to 2/10, and we're going to multiply it by 15. All right, and 2 times 15 is 30, but we can't forget our decimal. Whoops. Hold on, let me fix that. Decimal goes after. So we know 100% of 15 is 15, 20% of 15 is 3. Now, if you need any help figuring out that multiplication, I would definitely come see me in class if you need to understand that better. Next step, 120% of 15. Now, the standard way, again, that we would do this is we would turn that into a decimal, 1 and 2 tenths times 15. And if we solve that multiplication out, it will give us 18. But I wonder how many of you noticed that 100% plus 20% is 120%. So if 100% of 15 is 15, and remember that's plus, 20% of 15 is 3, all I have to do is add those. 15 and 3 make 18. All right, continuing on. 80% of 15. So we're going to set that up in that standard way. I can write 80 hundredths, 8 tenths. You guys will probably more often see it with that 0 in front of the decimal. I do forget to put that sometimes. But if we solve it out and do our multiplication, that should give us 12. One way we can check that is with our common sense again. If you guys noticed, 100% minus 20% gives us 80%. So the difference between 120 is 80. So the difference between 15 and 3 is, check my math for me here, 12. All right. If you need to, go back over, review this. These concepts are really important for remembering or being able to understand, rather, the rest of this video. And again, on that page of your packet, you should have this information, and you should not just have the answers. You should have the work. So all of this, plus your actual multiplication on the side, showing me how you solved it. That way I know that you didn't just go through and copy what I did, that you actually thought about it. Okay, so our goal for this first part is to not necessarily write this just as an answer, just figure it out, but I want you guys to be able to write it as an equation. So remember, we have been talking about English to algebra, so that's part of what we're doing. And luckily, for this type of problem, it's set up and we essentially just take the information from this English sentence and put it into a numerical sentence. This does take some practice to get, because I know as we're doing the problem, you might say, oh, that's easy. But sometimes when you go back and try to remember, it can be difficult. So if right away it's not super clear to you, that's okay. Write the notes down, practice it, and make sure you can solve these problems using any method in your arsenal of mathematical solving weapons. Okay, yes, I know, terrible pun, but continue on. What is our first word in the question? So what is what we are trying to figure out? Remember, is can be turned into an equal sign. 60%, that's our mathematical term, which we could turn into a fraction, 60 over 100, or a decimal, 6 tenths. Of, remember, when of is alone between two numbers, it's typically going to be that multiplication sign. Only when it's combined with other terms does it change. And then 60, again, just straightforward numbers. So let me pull this down here. Notice I've got these little arrows. That what goes to that unknown, that x, goes to the equal sign, 60%. Just wrote a 60% here of. Remember, I'm going to be using the little star this time, just because it's easier to type out and have ready to mean multiplication, and 60. So this is our mathematical algebraic equation. Now, again, we typically don't leave 60% like that in our equation, so I'm going to change that percent to a decimal or fraction in order to multiply or divide. So I just chose to change it to 6 tenths. Remember, if my decimal would be here and I move over 2 places, because essentially I'm dividing 60 by 100, because it's the same as the fraction, 60 over 100. I personally like fractions better, but I know a lot of you guys like decimals. So there we go. So in order to solve this, I would need to multiply 6 tenths by 60. This is when you should pause the video. Do the math, maybe over here on your paper, your notes. Then we have our answer. 6 tenths times 60 gives us 36. So are somewhere over here. Thought I had it typed out. Essentially, we're saying 36, right? That's what? 36 is 60% of 60. All right, next problem. It's same concept, but slightly different question. So this time I have 70, and I want to know 70 is 40% of what number? So I'm kind of going in a different direction. So you'll notice here, I've got my 70, stays here, is, comes down as my equal sign. 40%, I just pulled it down for now, of, right, multiplication, what number? That's my x, because what means I don't know. Again, must change my decimal, my percent to a decimal or fraction in order to multiply or divide. Just makes things a lot easier. I left it as a decimal for you guys, but you could have had 40 over 100, which simplifies to 4 over 10, which simplifies to 2/5. So I know 70 equals 4/10 times x. So hopefully you guys will remember that to undo this multiplication here, I want to divide. Now, I didn't write it here, but essentially, well, what I did on this side to cancel out that 4/10 was divide by 4/10, leaving me with x all by itself. You could have also used your knowledge of fact families to remember that we could rearrange this equation to tell us that x equals 70 divided by 4/10. So if I solve my math out, and that's what you should have done, I would have x equals 175. So I'd plug that back up in here when I say the full sentence or substitute it back in for what number. 70 is 40% of 175. Third type of question. Again, all percents, but this time we're actually trying to find the percent. So I have 32 is what percent of 40? Again, I'm just going to rewrite each part in order in an algebraic numerical equation. So I have my little arrows to show you. 32 is that equal sign, what, and remember it's what percent. So I just left that as an x, and at the end we have to remember to turn it into percent. Of is my multiplication, and 40 here. So 32 equals x times 40. It's similar to the last one that we solved in that we need that x all by itself. Again, I didn't necessarily write the divide by 40 on this side, but dividing by 40 would undo, would cancel out that 40, leaving x by itself. Or we could have used our knowledge of fact families to rewrite this. So I know x will equal 32 divided by 40, which x equals 8/10. But the question is what percent, so not just what number. 8/10 needs to be changed into a percent. Remember, 8/10 is 80 over 100. That's the whole point of what percent means, so it would be 80%. Or I could remember just the trick, I move my decimal over 2 places to the right to turn it into 80%. Okay, so what we've done so far is we have followed or used a sort of traditional creating a mathematical, algebraic, or numerical equation from the word problem. But I found this very helpful when I was in middle school, and it's one of the very few tricks I will show you guys because I'm not a big believer in necessarily tricks. I like to make sure you understand the concept and can build from there. But this is helpful if you are struggling with the writing the equations based off the word problem. And actually, I think you're going to come across something in science soon, which will not be exactly the same, but you'll use the same sort of format, this triangle format, to help you remember what to do for some mathematical processes you have in science. So if you come across that in science and you remember this and it helps you, or you come across this and you simply remember me talking about it, let me know. If you guys come back and you let me know, I'll find some way to reward you, maybe a RAM for showing motivation, enough respect that you were listening to me, that you're able to make the connection. Find some way to say, hey, great job for listening to both me and Miss Larson. But anyway, I usually just call this an is of percent triangle. So you'll notice I divided this triangle into three parts. Is always goes in the top. It doesn't really matter what order the of and the percent go. This is just typically the order I put it in. What we will be doing is we'll be placing numbers and variables in each of these sections based off the problem, and it will help us know what to do to solve. So one of the things we just need to remember is this line, like right here, it kind of looks like a fraction bar in that it's a horizontal line, and we'd have a number on top and a number on the bottom. And so we would know that this fraction bar would be a signal to divide. This line right here, it's just dividing these two numbers, and if the two numbers are next to each other, remember it's a sign to multiply. And then remember, when we are solving mathematical problems, we want to turn a percent into either a decimal or a fraction. So we're actually going to take a moment to look back at the first three problems again, and we're just going to use this particular method. So make sure you're following along in your packet. Make sure you're getting all this information down. Don't have anything to actually write down for this particular page. But, oh, here we go. Forgot I had this slide up. This is our division fraction bar, multiplication bar. All right, so what is 60% of 60? And I am going to show you how we break up the word problem and we put certain numbers in certain places on the triangle, and they help us know what to do. So on here, so here's the problem. I'm able to move stuff. On yours, you just need to write it into the appropriate place on the triangle. So I broke this up in that the is, notice there we have an is, matching is here, is next to the what. So we would put that here. The 60 is next to percent, so we would put that here. And the of is next to the 60, so we would put that here. The whole idea is it just helps us know what location and where to put stuff. This what going on means I don't have any number to put in this part of the triangle. But I do have a 60 to put here and a 60% to put here. And remember, if I have a number on this side of the triangle and a number on this side, I'm going to be multiplying them. So as long as you remember to turn this into a decimal or fraction, essentially, so we're doing 60 times 60%, or 60 times 6/10. That gives us 36. So I'm rewriting my original problem with, if you kind of look at this, what is 60% of 60? See how that matches this what? Is this 36? And that would be, remember how we ask you to write your answers out? This is kind of what we're looking for some days when we want you to actually write things out in a sentence. So you would restate it. You wouldn't just write 36 on the paper. You would say 36 is 60% of 60. But here, let me move these back up here because, put that in the right place. This is what I want to make sure that your packet has this information in the right place. So make sure you pause this if you need to and write all this information in the right place. All right, next problem, and we are roughly halfway done. I know this is a much longer video than normal, so if you need to pause it, you need it to take a break, you need to do something else, that's fine. But remember, that's why this is a week-long project, because I know you might not be able to watch this all at one time. And if for some reason you don't have Wi-Fi, you don't have the data to watch this all at once, remember that you can always do parts of it during homeroom. I might have some time during class today. Maybe if you finish the test early, you can use the Wi-Fi at school to watch this. But our goal is to get you taking these notes to really understand this, and then to be able to do the problems at the end for the project. But this is the same concept. You have a slide that looks like this. You cannot move these, so you have to write them in the appropriate places. But notice I broke it up so that a number is next to one of the words in our triangle. This number is next to the is, this number is next to the percent, this of is next to the what, because remember, a what is like a variable we're trying to figure out. So I move my 70 here, goes with my is's. My 40 is my percents, and it won't exactly fit in there. Let's see. My of what number here? There we go. So clearly I don't have anything in this of space here. I only have something in the is and the percent. Remember, this is like a fraction bar, so I'm doing 70 divided by 40%. Ta-da! And remember, must change the percent to a decimal or fraction in order to multiply or divide. So 40% is the same as 40 over 100 or 4 over 10 or 4 tenths is a decimal. And if I work this out, 70 divided by 4 tenths equals 175. And I'm actually going to try to write this over to the side. It'll be a little messy because I'm moving it with a mouse to help some of you see how we might set up this division problem. Hold on. So remember, the first number, the number I'm breaking up, goes on the inside. And the number I'm dividing by goes on the outside. And as a general rule, we do not like decimals in our division problems. We want to deal with them after, kind of like with multiplication, we like to deal with them after. So 4 tenths, if I multiply it by 10, it will give me 4. But like with everything else in math, we need to keep things balanced. So I need to multiply 70 by 10 to get 700. So I'm going to write that little 0 here. I'm going to take a moment. I'm actually going to erase the decimal movement line. So you can see I've essentially rewritten it like this. Alright. So I would say 4 comes out of 7 1 times, because 4 times 2 would be 8, and we can't take 8 out of 7. But 1 times 4 is 4, so remember I do this, I subtract, 7 minus 4 is 3, and I bring down a 0. Now, you can just bring down 1 0 at a time, which is how I tend to do it. If you want to, you can bring down both zeros and just keep working from there. So now, alright, change the color up so we see what we're doing. I want to see how many times 4 comes out of 30. So you might have to count by 4s, or if you feel really comfortable with your number sense, your multiplication, you would know that 4 times 7 is 28. 4 times 8 is 32, which would be too big, so which would mean 7 would go here. So 4 times 7 is 28. Subtract that, that gives me a 2. I'm going to bring down this 0 all the way here, which gives me a 0 here. Alright, and let's see, last step. 4 now comes out of 20 5 times, and 4 times 5 is 20. Subtract that, we're left with 0, so I have no decimals remainder. And this right here is my answer, 175. See? So matches like this. Now, I know a lot of you have been practicing the method for division, and some of you even you understand the concepts, but that's actually what we're going to be doing after this upcoming test, is not only just practicing how to do it, but understanding why we do it this way. All right, next problem. 32 is what percent of 40? The 32 is next to the is. Is. Of is next to the 40. Right here. So this leftover, what is next to the percent, goes here. Nothing is here because it's a what? So I've got 32 divided by, remember this fraction bar, 40. Remember, pause this if you need time to really look at it and to write it down to understand it. So 32 divided by 40. And I already wrote the answer here, is 8 tenths. And then it's important to make sure that you change your decimal or fraction to a percent, because that's what we're looking for to be in this particular part. We're looking for a percent answer. So 32 is 80% of 40. And let's see, let's go ahead and solve that out anyway, get some of that practice in. Remember, 32 is the one being divided. I know it's smaller than 40, but if I'm dividing it by a number that's larger, that means we're going to get something smaller than 1. And this one really comes down to a lot of number sense or really working it out, because there are no decimals in this problem, but 40 can't go into 3 and 40 can't go into 32. So I'm running out of room. Put my decimal here, bring it up, put it up here, add a 0. Can 40 go into 320? Yes. Now the way I like to think about that is, just to make it easier, I say, okay, let me get rid of those zeros real quick, and how many times can 40 go into 32? Oh, it can go into 32 8 times, because 4 times 8 is 32. So I would just go ahead, and that would be my answer right here. Again, this is something we will continue practicing the division, but at least if you can understand how to use this is of percent triangle. Ideally, we want to move from understanding the expressions, because that's what this is. When I know 32 divided by 40 and I just solve it out to get an answer, this expression is something that I'm solving. And I really want to be able to write those equations like we did in the first part of the video, where we had x as part of it and we were trying to solve for x. And remember, equations have something on both sides of the equal signs, where essentially I only had this part on the on this side of the equal sign after I had solved 32 divided by 40. All right, yes, I know, we're still going. We have about 4 questions which we are going to solve out, and we're actually going to write an equation to determine these. But if you want to, and I actually think this is a really great idea, look at this question, pause it, and you try to figure it out. And you can use any method you want to try to figure it out. Remember, use the information, obviously, that we've learned already, but then see if the equation and the way that we solve it matches the way that you solved it. And then that means you understand what you're doing, you understand the connection, the relationship. Maybe you just do it a little bit differently than we do. Okay, so these are actually previous test questions. So they should look a little familiar to you. So this one is: Carlos' restaurant bill without tip was $24.50. Carlos will leave a 20% tip. Yes, I see the typo. We're just going to ignore it for now. So our first goal is to write an equation to determine how much Carlos will leave just as a tip. So essentially, we want to figure out what is 20% of $24.50. So remember that this what is like an x. So what is 20% of $24.50? So essentially what you need to do is you need to do the multiplication. All right, so I've got 24.50. I'm multiplying. I don't really need that 0 at the end because it's after the decimal point, so it doesn't make any difference. And I'm going to multiply it times this 2/10 here. I had to think a moment, make sure I said it the right way, because you know sometimes want to say 0.2, but we want to make sure we're saying it as 2/10. All right. Yes, I know that was a little bit of a crooked line, but anyway, 2 times 5, work this out with me, is 10, carry my 1. 2 times 4 is 8, plus 1 is 9. 2 times 2 is 4. All right, now I need my decimal placement. I've got 1 number to the right of a decimal, 2 numbers to the right of a decimal. So I go 1, 2, and here we go. my answer for what is 20% of $24.50, and it's money, so I want to leave that in. It is $4.90. Now, that is the first part. I have my equation for it. I solved it. Now we need to write an equation to determine how much Carlos will pay altogether. So that means the 100%, his original bill, and his 20% tip. Now, the important part here is we want to make sure that we are writing the equation. That is our emphasis right now. So, some of you will have maybe said, okay, well, I need to know what is 100% of $24.50 and what is 2% of $104.50. So you might have said 1 times 24.50 plus 20% times $4.50, which we worked out will give us $24.50 plus $4.90. All right, now that is fine, but I want to build on something that we looked at in the warm-up and and look at the distributive property and really kind of turn this into a more streamlined answer. And in fact, this is actually an expression at the moment because it doesn't have an equal sign or a variable in it. So I want to look at, this is 100% and 20%, and it's of the same amount, this 24.50, 24.50. And yes, I know I didn't put my 0 in here, but it would still have been the same amount. So I could go ahead and take out this $24.50. Let me change it to a little bit different color so we can see the difference. And it's being multiplied by this 1 and this 20%. So remember this distributive property, because this gets distributed to the 1, like this 1 over here, and this gets distributed to the 2/10, like this 2/10 right over here. But I can rewrite it like this, because remember, we're doing $24.50 times 120%. And to make it an actual equation, I need my equal sign and the variable that I am solving for. So in this case, you could actually solve out the math, 1 2/10 times $24.50, or you could simply add these together here. So let's see. And I'm actually going to just do the adding together at the moment, and then you can check my math through multiplication. All right, so sometimes I'm going to do it mentally. $24 plus $4, that's $28. I like to deal with the bigger amount, $28 plus 90 cents, $28.90. $28.90 plus 50 is $29.40. And that should be our final answer. We're actually going to check it to make sure everything worked out here. So I've got my $24.50, right? And I multiplied it times 1, which stands for 100%, and 2/10, which stands for 20%. And it equals 29 4/10, which does indeed match our $29.40. All right, next question. Katrina took a group of friends to a restaurant for dinner. The cost of the dinner, including this time the 18% tip, was $289.10. what was the cost of the dinner before the tip was added? All right, so our goal here is to figure out how to write this as an equation. Now, we have the cost of the dinner and the tip was $289. So let's put our $289.10 because we know this will be part of it. Now you see this was here. It's actually the same as is. It's just past tense, and so it is an equal sign as well. So it was $289.10. Now we want the cost of the dinner. The cost of the dinner is the unknown, right? So we would say X, the cost of the dinner, and, right, the 18% tip. Well, remember, 18% is 18, based on the last one we did, 18% of the dinner. So this is the cost of the dinner and 18% of the dinner. And it equals $289.10. So there's that equation, but I'm going to combine these like terms because remember we talked about, so we can put those x's together just like we did for the last problem where we did the 120%. So I've got the cost of the dinner, that 100% of the dinner, and 18% the tip of the dinner, that's my variable, equals 289, or was $289.10. So here we have an equation to help us determine this information. Now ideally what you will have done is said, oh okay, I want x by itself, so I know how to solve this problem. In order to solve this problem, I know that I want to divide both sides by 1 and 1800ths. Ooh, that's a very messy 8, but I think you guys see what is going on. And that will give me what x equals. Now, I'm actually going to do this on our calculator because we've taken a moment to look at how to do it by hand, but I've noticed some of us are not always entering it into our calculators correctly for the calculator sections of the test, so let's make sure we really know how to do it. The first number we're dividing is the number that we enter. If you just type in 1 for 1/10, or you type in the 0 as well, makes no difference because the 0 is at the end, it's after the decimal, so we could leave it there or take it off. Then we're going to divide, because that's what that fraction bar means, by 1 and 1800ths equals $245. So the cost before the tip was $245. Now we could also check that by saying, okay, well, what is 18% of 245? Remember, 18% of, so I take this 245 and I multiply it by 18%, which we would leave as 1800ths, $44.10. If I add that to my original amount, which what did we say was $245, that gives me $289.01. So I know I'm going through that a little bit quickly. I'm building on some information that we talk about frequently, that you've practiced in the past, but if you have a question on it, feel free to ask me in class, ask in the comments, anything that you can do to help get any sort of clarification. Alright, a wool sweater that usually costs $58 is on sale for 15% off. How much money can be saved by buying the sweater when it is on sale? And I want you to pause this and really think of how to solve this problem. And can you think of 2 methods to solve this problem? because there are two different ways which are actually the same way, just a little bit different way of approaching it. Okay, so the first thing we might want to do for one of the ways is ask what is 15% of 58? And so we would turn that into a decimal or a fraction and multiply it by 58. And while I think you should practice your traditional multiplication, whichever way you choose to use, it should give you 8 and 7/10. The important part of this problem, though, is it says how much money can be saved. And I think that's a big problem for a lot of us, is we don't necessarily look at what it's asking. So, how much money can be saved by buying the sweater when it is on sale? Now, a lot of you did this. This is the most straightforward way. We're looking for how much is saved, not how much the sweater actually costs, which I think is what some of us did on the test. And so the most straightforward way of solving this problem would be creating that 15% of x. Sorry, my bad. Hold on. What is 15% of x? So x equals, that's my is, 15% times 58. So this would be my equation at the moment, and luckily it's set up nice and neat with x all on its own on one side. And that would tell us how much money can be saved. Now, there's sort of a roundabout way that you could have done it, or if we think about it, may have helped you find out how much not can be saved, but how much does the sweater cost now? So some of you said, okay, well, if the sweater is on sale for 15% off, that means the sweater costs 85% of $58, because 100% minus 15% equals 85%. Now, it's sort of an unnecessary way to go about doing this, but I'm addressing it mainly because I saw several of you doing this, and I want to make sure we see how these two things connect. So, some of you guys said, well, what is 85% of $58? And you went ahead and you solved that out to equaling 49 and 3/10. And then you said, okay, well, the sweater originally cost $58, but I bought it for $49 and 3/10. So the difference, remember subtraction is the difference, will be the amount that I saved, and that is $8.70. Now the reason I'm going over this again, some of you did it this longer way, but also I think it's important to see how these two ways are connected, because we can still create an equation for that, in that some of you guys said 100% of $58, and then you subtracted the 85% of $58 to get X. Well, looking at what we did earlier in one of the other slides, remember these both have 58 in common here. So I can kind of pull 58 out, something called factoring. They are both a factor of this multiplication problem and this multiplication problem, so I can pull it out. And then I can have my 1 from here, keep my subtraction sign, and my 85% here. So 58 times the difference between 1 and 85%, which actually gives us 58 times 15% equals X.